Today we're going to talk about equivalent fractions. In particular, we're going to talk about how to build equivalent fractions and then how to actually reduce equivalent fractions. So today I want you to just get through some of the basics and we'll just work through it. It's not a whole lot of material to cover today. You can see that there's only 4 slides, and the first was a title slide, and this one is the objective. So there's only really 2 main points out of this, but these 2 main points are very valuable for you to understand. We're going to call 2 fractions equivalent if they have the same value. So equivalent fractions are fractions which represent the same number or the same value. The example I've given you that I'll sort of work with for a little bit here is 3 halves. So there's a couple of ways of thinking about 3 halves. The number 3 halves is the same as 3 halves times 1. If I multiply anything by 1, I don't change its value. So just make a note of that multiplying by 1 doesn't change its value. But 2 over 2, so this 2 over 2 here, is just another way of writing 1. Since that's another way of writing 1, I can say that 3 halves is the same as 3 halves times 2 over 2, and that's the same as 6/4. So we would say that 3 halves is equivalent to 6/4. So these are equivalent fractions. Here's another example. So 3 halves, well, again, 3 halves times 1. So that tells me that 3 halves is the same as 3 halves times 4/4. When I multiply these out, 3 times 4 is 12, 2 times 4 is 8. What I find is that 3 halves is the same as 12/8. So again, an equivalent fraction, 3 halves, is equivalent to 12/8. So this is the basic idea of equivalent fractions. So let me give you one to work on here for just a minute. 3 halves is equivalent to what? Well, in this case, I'm looking for 3 halves over 10 is equivalent to something over 10. And so what is that something? Well, how do I get from 2 to 10? So the key here is to recognize that to get from 2 to 10, I need to multiply by 5. That tells me that if I multiply by 5 in the top, I will have an equivalent fraction. So what I'm essentially saying is that 3 halves times 1, which in my case would give me 3 halves times the number 1. Sorry, my writing isn't working here, so I'm going to go ahead and skip to the next slide so that you can sort of see what it is. 3 halves is what? Well, it's the same as 15/10. So let me go back a slide and see if I can make this work for you. So 3 halves times the number 1 is the same as 3 halves times 5/5, which is the same as 15/10. And so that is exactly what we have here. We have 3 halves is the same as 15/10. So we would say that 3 halves and 15/10 are equivalent fractions. We can also talk about when a fraction is in lowest terms. So we will say that a fraction is in lowest terms when there are no common factors between the numerator and the denominator. So let me give you an example. 24 is written as 3 times 2 cubed. So that is the factorization. Remember back from our section on factorization, that is the factorization of 24. The factorization of 120 is 5 times 2 cubed times 3. Therefore, 24 over 120 is not in lowest terms because there are factors in common. Specifically, you'll notice that both of these have a 3 and both have a 2 to the 3rd power. And so I can cancel those out, and I'm left with 1 over 5. Let's do one more just to sort of highlight something here. Why don't you imagine I had 12 over 120? this would be the same as 3 times, no longer 2/3, but it's actually 2 squared, divided by 5 times 3 times 2 cubed. The cancellation isn't quite the same, so I'm going to get cancellation there. But here, what I can do is I can rewrite this as 2 squared divided by 5 times 2 squared times 2. And then I can get that cancellation, and so I actually get 1/10 in that case. So this is how you reduce fractions. And this will become important whenever we work with fractions. It's just easier to work with reduced fractions. There's no rule that says we have to reduce every fraction we see, but it is easier to work with reduced fractions.